Now we're going to take a look at some two-step equations. And basically, a two-step equation is where there are two operations taking place. And remember, operations are things that you can do in mathematical terms such as adding, subtracting, multiplying, or dividing. What we need to do when we're trying to solve these kind of equations is we need to apply the inverses, and we have to do that in the correct order. Now, if you remember, an inverse was what you do to undo an operation, and we need to make sure we use the correct inverse and definitely in the right order. The key skill when we're trying to solve a two-step equation is we need to be able to read the algebra. We need to be able to look at it and see which two operations have taken place, and crucially, what order did that happen in. Okay, let's have a go at an example of this. Okay, let's try and interpret this algebra. I'll give you an example and then we can see if you can determine which operations have taken place. The example will be 3x plus 4 is equal to, we'll say, 19, and we know that it was the variable x. Because it's in this presentation, you can tell that it's going to have two steps, so we know that's going to happen. The answer when those two steps have taken place is 19. But what has been done to x? And your task is to identify the two operations and the order in which they took place. Well, the first operation was to multiply by 3 and then add 4 is the second operation. So here's another example of this algebra that we need to interpret. If you look at this one, we've got the variable x still, and we've got two operations. So we start with x, two things happen, and we end up with the number 13. So what things happen? Well, we have a multiply by 5 and a subtract 7. But the really good thing about this, and why this relates to solving equations, is once you can do this, once you can go from the algebra, which is written up here, once you can look at this and in your mind understand the processes, the operations that have taken place, then you can begin to reverse it and solve the equation. So let's have a go at doing that. Reversing it means we would start at 13. We would work back towards finding what x is. I need to understand about inverses again. So the inverse of taking away 7 is what you would do that's the opposite of taking away 7. So that would be adding 7. Continue towards moving to find out what x is. I need to do the inverse now of multiply by 5. And the opposite of multiplying by 5 is to divide by 5. And so this should help me go from 13, add 7, which would be 20, divide by 5. I now know that x must have originally been the number 4. Hopefully you'll want to move your algebra beyond the level of those function machines. So what I'm going to get you to do next is to look at a different way of setting out that same thought process of undoing algebra that's taken place. The golden rule when writing down equations and solving them is whatever you do on one side of your expression and equation, you must do the same on the other side. If we have the example 6x plus 3 equals 27, you should recognize that as a two-step problem. How do we undo that then? Well, the first step was to realize what's taken place. We had a multiply by 6 and then an add 3. And I need to undo those things, and I need to make sure I do it in the correct order. The first thing I undo is the last thing that took place. So the first thing I need to undo is the plus 3. So I need to take away 3. Now the golden rule of algebra when solving equations like this is whatever you do on one side of your expression, you need to do exactly the same on the other. So I'm taking away 3 because that will leave me with just 6x on this side. I need to take away 3 from the right hand side, which leaves me with 24. Now you can see this already looks like a simpler thing to tackle. I've got one more operation to undo, and I need to find the inverse of multiply by 6. And we should by now be really comfortable in knowing that that would be divide by 6. And as I said, the golden rule is to do the same thing on both sides. The reason we're doing it is to undo that multiply by 6. So I'm left with just x on the left hand side, and I've learned that the answer must be 4.